Hello students, last class we have discussed with the methods of preparation of aldehydes, that is the first two methods. The first one is by oxidation of primary alcohols and the second method of preparation was by catalytic dehydrogenation of primary alcohols. Now the next method of preparation, as I have already told, is a named reduction reaction called as Rosenmund's reduction. It is called as Rosenmund's reduction. Both aliphatic as well as aromatic aldehydes can be prepared by Rosenmund's reduction by taking an acyl chloride or acid chloride as the starting material. Now just look to the reaction there. The example taken is that of benzoyl chloride, C6H5 double bond OCl. C6H5CO group is called as benzoyl group. So benzoyl chloride reacts with a mixture of hydrogen H2 in the presence of palladium. The symbol for palladium is Pd, supported over barium sulfate BaSO4. Cl of benzoyl chloride is replaced by H, so that you will get the product as benzaldehyde C6H5CHO plus HCl. So this is a named reduction reaction called as Rosenmund's reduction. Yes. So students, in this chapter you come across a number of named reactions. Don't get confused. You should write and rewrite and practice so that you will remember the named reactions and not get confused. Next method is once again another named reaction called as Stephen reaction. Stephen reaction is from nitriles, the method of obtaining aldehydes from nitriles. So nitriles have the formula RCN. In the expanded form, if we indicate there is a triple bond between carbon and nitrogen. Nitriles can be reduced to corresponding imines. Imine, IMINE, have the group CH double bond NH in them. Now this can be done by using stannous chloride, SnCl2 is stannous chloride, and hydrochloric acid 2HCl. Now the two hydrogen atoms present in HCl add across the triple bond of Cn. So that triple bond is converted to a double bond and you will get the imine as RCH double bond NH. The other two chlorine atoms are picked up by SnCl2 to form the byproduct stannic chloride SnCl4. This further imines are subjected to hydrolysis. RCH double bond NH is an imine plus H2O. Hydrolysis will give you simple boiling. H2 and NH is eliminated as NH3 and you will get the product as RCHO aldehyde with the liberation of ammonia NH3. This reaction is called as Stephen reaction. To give one particular example, you can take CH3CN. Methyl cyanide or ethane nitrile reacts with stannous chloride and hydrochloric acid to form the corresponding imine CH3CH double bond NH plus SnCl4 stannic chloride, and further this ethane amine on hydrolysis will give you CH3CHO and liberation of ammonia NH3. This reaction is called as Stephen reaction. Further, the nitriles can also be reduced to imines by considering another reagent called as, yes, look here. It is diisobutyl aluminium hydride. Now, iso prefix is used for the group CH3 twice CH. If you look to the structure here, there is one more carbon, CH3, CH, CH3, CH2. That is isobutyl group. Twice is there, so therefore it is diisobutyl. Aluminium hydride, so outside the bracket it is AlH4. Now this diisobutyl aluminium hydride is abbreviated as DIBAL-H. Yes. So it is abbreviated as DIBAL-H, all capital letters. So DIBAL-H can also be used to reduce imines so that you will get aldehydes on hydrolysis. To represent the reaction equation, I will just show the general representation of the equation RCN. Each time you need not remember the structure of DIBAL-H. Yes. So RCN nitriles on reduction with diisobutyl aluminium hydride followed by hydrolysis will give you aldehyde. Now this reduction can also be carried out using esters. The general formula of esters is RC double bond OR dash. Esters in the presence of diisobutyl aluminium hydride DIBAL-H and followed by hydrolysis, the ester functional group is converted into aldehyde group RCHO. So these are the other reactions. Now coming to the next method of preparation, another named reaction, it is from benzene. The next method of preparation is from benzene, and the name of this reaction is nothing but Gutterman-Koch reaction. It is called as Gutterman-Koch reaction. Now in case of Gutterman-Koch reaction, benzaldehyde is obtained from benzene by passing the vapors of carbon monoxide CO and hydrogen chloride gas HCl in the presence of either anhydrous aluminium chloride AlCl3 or cuprous chloride as a catalyst. What happens is the CHO group is introduced into the aromatic ring. Actually, to obtain the CHO group, the reagent required is formyl chloride. HCOCl is formyl chloride, which is obtained by the reaction between carbon monoxide and hydrogen chloride gas. This formyl chloride HCOCl further reacts with benzene so that you will get benzaldehyde and HCl. That is, formyl chloride is prepared in the reaction mixture itself. It is not a stable compound. It is prepared in situ. So the other two steps for the same reaction I have indicated so that you will understand it much more clearly. Formation of formyl chloride in the first step, and in the second step this formyl chloride reacts with benzene to form benzaldehyde and HCl. This is the actual reaction. If you write it in a single step also, it is more than sufficient. This is for your understanding. So this named reaction is called as Gutterman-Koch reaction. Once again, a very, very important reaction usually asked in the examination. Now the next method of preparation is from toluene. There are different methods from toluene. The first one is by oxidation with the chromyl chloride. Now you have come across chromyl chloride, CrO2Cl2 is called as chromyl chloride. While carrying out your salt analysis in the laboratory, confirmatory test for chloride, you have come across chromyl chloride which has the formula CrO2Cl2. Now the methyl group of toluene is oxidized by chromyl chloride CrO2Cl2 in the presence of carbon disulfide CS2 or carbon tetrachloride CCl4, so that an unstable intermediate, the two hydrogen atoms of methyl group, are picked up by the oxygen of chromyl chloride CrO2Cl2, and you will get a brown colored chromium complex. O becomes OH there if you look into the complex, which is highly unstable and immediately on hydrolysis decomposes to form the aromatic aldehyde benzaldehyde. This reaction is a named reaction called as Etard reaction. Once again, another named reaction, students. So this is Etard reaction. From toluene itself, there is one more method by oxidation with chromic oxide. Chromic oxide has the formula CrO3. So here you will start with once again toluene and treat it with chromic oxide in acetic anhydride. Acetic anhydride has the formula CH3CO twice O, and the nascent oxygen here 2O written in square brackets is obtained from chromic oxide CrO3. The temperature to be maintained is between 273 to 283 Kelvin. Once again, the two hydrogen atoms of methyl group are involved in the formation of a diacetate, gum diacetate in particular, which is called as benzylidene diacetate. This benzylidene diacetate is subjected to acid hydrolysis, once again H2OH plus, so that the side chain is replaced by the aldehydic functional group. You will get benzaldehyde and CH3COOH, that is acetic acid, or its IUPAC name ethanoic acid. And one more method, the last method of preparation from toluene, is by side chain chlorination followed by hydrolysis. Side chain chlorination followed by hydrolysis. Now in this method, we use chlorine for side chain chlorination. The two hydrogen atoms of methyl group are once again replaced by chlorine, and you will get C6H5CHCl2, which is called as benzyl chloride. And this benzyl chloride at a temperature of 373 Kelvin on hydrolysis, acid hydrolysis in particular, you will get the aromatic aldehyde benzaldehyde. So once again, from toluene there are three methods of obtaining the aromatic aldehyde benzaldehyde. So these are the different methods of preparation of aldehydes. I hope the methods of preparation of aldehydes is clear to you all. Next is to know something about the physical properties of aldehydes. Now, the very important first point is that the first member in the nomenclature, I have written the structures of all these compounds. Formaldehyde, its IUPAC name is methanol. Formaldehyde or methanol is a gas at room temperature, whereas most other aldehydes are liquids at room temperature. You need to remember this, students. Other aldehydes are liquids at room temperature. Another important physical property, lower aldehydes have unpleasant odor, whereas higher members or higher aldehydes will be having a pleasant odor. Odor means smell. Regarding solubility, lower aldehydes in particular up to 4 carbon atoms, lower aldehydes up to 4 carbon atoms are soluble in water. Up to 4 carbon atoms, they are soluble in water. Now this solubility is due to the ability of aldehydes to form hydrogen bonds with water molecules. They have the ability to form hydrogen bonds with water molecules. Therefore, they are soluble in water, whereas higher members are soluble in organic solvents. So these are a few important physical properties of aldehydes. Hope the different methods of preparation and physical properties of aldehydes is clear to you all. Next class I will